Okay, everyone. We are going to start with polar and rectangular coordinates. This is section 7.1 in your book. Now, as far as polar coordinates go, we're used to the rectangular coordinate system, the Cartesian plane, if you will. And where would we use something like polar coordinates? Well, anytime you have a central location and you're trying to attract objects from that central location, you can use polar coordinates. A lot of time, radar uses polar coordinates. Airplanes, anything like that has a central hub where they're coming and going from, or being tracked from, can use a polar coordinate. So, as far as polar coordinates go, how do we form one? Well, what we're going to do is we're going to start with a fixed point. We're going to call that point O. Okay, and from that fixed point, we can draw a horizontal ray or a horizontal line, and this is what we call the pole. This whole thing is called the pole. Or excuse me, the dot is called the pole. The whole thing is called the polar axis. The polar axis. Okay, so now in terms of how we get our polar coordinates, we start with the pole, just like normal, and any point P, okay, any point P, which point P would be at the end of our ray here, point P is equal to r theta. R theta is point P. And theta is the angle between the pole and the line R here. Okay, that would be how we get polar coordinates. Okay, now in terms of R and theta, the theta coordinate, that's the angle, okay, in degree or radian measure, just depends on the problem, and it's positive in counterclockwise rotation and negative in clockwise rotation. The R coordinate, that's the distance from the pole to P, okay? It is positive if the measure from the pole is along the terminal side of the angle, and negative if it extends through the pole. And I'll show you more about that. It'll make more sense here in a minute when we actually do an example. Okay? So, what's the difference between the Cartesian system and the polar system? Well, the rectangular system, each point has one pair. The point 1, is only the point 1. You can't find the point 1 anywhere else, okay? However, the polar system, a point may have infinitely many polar coordinates. A good example is the pole itself. The pole itself has the coordinates 0 theta. So 0, 37 degrees would be the pole, and 0, negative pi over 4 would be coordinates of the pole. There are infinitely many coordinates for the pole, okay? As I said, for many of these polar coordinates. So let's look at an example. Okay, so let's change the color here. And let's look at trying to plot this one here. Let's try to plot A equals 445 degrees. So here's how we're going to do this on the polar coordinate system. Find 45 degrees, well, right here it is, and we're going 4 units from that. 4 units up to that. So 1, 2, 3, 4. This would be, this point right here, this would be positive 4, 45 degrees. Okay, does that make sense? Let's look at another one. Let's let B equal negative 6 and 45 degrees. All right, same 45 degree line, but notice positive went in this direction, 4. Positive goes in the direction where the terminal is. where the terminal angle is, okay? So it's in quadrant 1, so the positive direction will be quadrant 1. So to go -6, we would have to go 45 degrees, but we would go backwards 6 places. So 1, 2, 3, 4, 5, 6. So this right here would be point B. That's the same. I know it says 225 there, but that's 225 if it's in the third quadrant. In the first quadrant, that's the negative R of 45 degrees. Okay, so keep that in mind. That line runs all the way through the origin. All right, so let's look at another one. Let's let this be C. Let's do 240 degrees. So 240 degrees is right here, and 7 would be in this third quadrant. So that's going to be the positive quadrant because the angle's in the third quadrant. So that's going to be 1, 2, 3, 4, 5, 6, 7. So this right here would be C. And last but not least, let's try, for this first degree version graph, let's try 3, -75. Well, where is -75? Okay, that's going to be right in here. It's going to be right in here because -75 would leave us 25 degrees to get into -90. So it's going to be somewhere right in here. Okay, it would be -75, and it's +3. So we're going to come out 1, 2, 3. So this would be D. Now I didn't have it marked. I didn't have the angle marked. This is just our unit circle angles that are marked here. You could very easily go draw you a line here and say that this is -75 degrees, okay? Or you could say that it is, what would -75 be? Okay, so just think about that. 295, right? So that would be 295 degrees if you were looking at the angles as they're stated in positive form. Okay? Alright, so now notice we've just been working on this degree side. Let's look on the radian side. So this is 8 pi over 6. So it works the same way. Okay, go to where pi over 6 is, and we're going to go out 8. Okay, so let's just assume that these are worth 2 each. So we're going to go 2, 4, 6, 8. So that's 8. So that would be letter A right there. Okay, just assume that those lines are worth 2 each. Okay, since there's not enough room on that graph. All right, so let's look at another one. It works the same way the degree does. We're not going to do too terribly many of the radians because it works the same exact way. You're just dealing with radian measure. So let's look at -7, 2 pi over 3. Okay, so 2 pi over 3 is right here. And -7, this would be the positive direction here. So find that through here, the negative direction. 2, 4, 6 of 7 would be halfway in between here, so that would be B. Okay, so be able to plot these polar coordinates. Alright? Okay, so now the major part of this is going to be converting to and from polar and rectangular coordinates. So here's how they're related. Notice that r squared equals x squared plus y squared, and notice the trig functions here. But one thing I want you to notice about how they're related is this down here at the bottom. Notice that the angles are chosen between -180 and 180. They're chosen between -180 and 180. And you'll see how that makes a difference here in a minute when we work a problem, okay? But we'll apply some of these things here in just a second. Alright, so let's look at example 2. And what example 2 says is this. Example 2, let's change this polar coordinate to a rectangular coordinate. This polar coordinate to a rectangular coordinate. Well, if you look at that pink table that we just had up there on the screen, if you rewind the film back to look at it, a rectangular coordinate is in the form xy, right? Not r theta. So how do we change this? Well, remember, if you look at that pink box I showed on the previous screen, x equals r cosine theta, and y equals r sine theta. So all you're going to have to do, plug in your r, plug in your angle. Plug in your r, plug in your angle. Okay, so this is going to be 5 times the square root of 3 over 2, which is going to be 5 square roots of 3 over 2. And this is going to be 5 times 1/2, which is 5 over 2. So our rectangular coordinate here would be 5 square roots of 3 over 2, 5 over 2. That would be our rectangular coordinate. Alright, so no biggie there. It's just a matter of you being able to read your unit circle and to be able to change it from one coordinate to the next, okay? There are some more examples of those. If you want to see more examples of those, turn in your book and you'll see this is example 2 in your book. There are 2 more examples like this one. For sake of time on a video, I'm not going to work them out because they're worked exactly the same way. So just make sure if you're confused with this one, look at those other 2 examples. All right, so we went from polar to rectangular. Well, what about going from rectangular to polar? Well, first of all right, let's look at this point here. A equals 1 square root of 3. So this is our x, y coordinate here. We're trying to change it to polar coordinates. Remember, polar coordinates are r theta. So I can get r very easily because remember, r squared equals x squared plus y squared. So r squared is going to be 1 squared plus the square root of 3 squared, which is going to equal 4. So r is going to be 2. Now we know r is going to be 2 here because a is in the first quadrant. It's not going to be negative 2. We know it's going to be positive 2 because a is in the first quadrant. This is a Q1 point, okay? So that's my r. My r is 2. Well, what about my theta? Well, since we know x and y, we know tangent theta is y over x. So I know tangent theta here equals the square root of 3 over 1. So what angle has a tangent theta of square root of 3 over 1? Now don't use your calculator. The habit is to use your arc tangent button, your inverse tangent button, to get this real quickly in decimal form. I don't want this one in decimal form because I want the radian form of it first of all. Secondly, this is a unit circle angle. Square root of 3, 1 comes out of unit circle angles. So which unit circle angle, if I took the tangent, if I did y divided by x, would give me square root of 3 over 1. And that's going to be pi over 3. Pi over 3. That's 1/2 square root of 3 over 2. If you did y over x there, you would get square root of 3 over 1. Okay, if you did y over x. So, now, how did we know this was pi over 3? How come it wasn't one of the other pi over 3? It's in quadrant 1. So we're looking for theta in quadrant 1. That would be pi over 3, okay, for this particular angle. So keep that in mind. So our polar coordinate here is 2, I wrote r here. It's 2 from getting our r there, pi over 3. 2 pi over 3. Alright, so let's look at another one. The pi to pi didn't really, the negative pi to pi didn't really come into effect here because it was a quadrant 1 angle, and that's in that interval. Okay, that is in that interval. But let's look at an angle that's not in that interval. For instance, letter A here. Suppose these are my rectangular coordinates. My xy is negative 6.434, and this is 4.023. Okay? Well, we're trying to convert this to polar. So we would do this the same way. R squared equals x squared plus y squared, or r equals the square root of x squared plus y squared, either way. So just plug them in. Plug your x in for x, your y in for y. And so when you do that, negative 6.434 squared plus 4.023 squared. And what that gives you here is r equals 7.588. So that's my r of my rectangular coordinate, 7.588. So now we've got to find theta. Okay, well, again, we're going to use tangent theta because we know y and x. Y is 4.023 and x is negative 6.43. Well, you have no choice. You have no choice but to use your inverse tangent for this particular problem. You have no choice but to use inverse tangent. Okay? And if you use your inverse tangent here to get theta, inverse tangent of 4.023 divided by negative 6.434. So I'm going to do that on my calculator here. And make sure your calculator's in degree mode because we're solving this for degrees. If you look up here at the problem, negative 180 to 180. So make sure your calculator is in degree mode. And go ahead and do the arctangent of that division problem there. And what you get is you get negative 32.02. Negative 32.02. Now, that's fine and dandy, but think about something here. Where is negative 32? It's somewhere down in here, right? Where is this angle? Well, look back at the original coordinates. What quadrant are those original coordinates in? Negative 6, positive 4. Uh-oh. That's a quadrant 2 angle. So here's where we have to look back at what our angle has to be in. It has to be between here, but it also has to be, and it is, and we will keep it there, but it also has to be in quadrant 2 because that's where the point is. So this is what our calculator gave us. So in order to get back to this same area over here, what do we have to add? Well, what is the distance from here to here? Well, that's half a circle, and half a circle is what? It's 180. So we have to add 180 to our answer there to get the angle in the right quadrant. That is why we're doing that. We're trying to get the angle in the right quadrant. And that's going to be 147.98. So 147 0.98. So there's our R, there's our theta. So that's where you got to be careful. Make sure your theta falls in this interval, and make sure it's in the right quadrant. And if it's not, you may have to add 180 or whatever to get it back to that quadrant. Okay? So keep that in mind. Keep that in mind. All right, so letter B. Let's go from polar to rectangular now. So here's our polar coordinate, r theta. And r theta, r is 8.677, and negative 1.385 is our theta. Now notice that theta here, this is theta, this is r. That theta is in radian form, so make sure your calculator is set in radian form. So remember our conversions, okay? You got to go back to that pink table that I had up there earlier. Remember, we're trying to convert this to rectangular form, to XY form. And so X equals R cosine theta, and Y equals R sine theta. So plug in, so it's going to be 8.477 times the cosine of negative 1.385, and this is going to be just the sine version of it. Okay, just the sine version. Okay, so go ahead, make sure your calculator's in degree mode. Going to be very important to get it right, and punch it out, and you'll have your XY coordinate. And so this is 1.603 and negative 8.528. Now I'm sure some of you have already noticed this, that that the only one we're really having to pay attention to the angles on, and what quadrant is in and all that, is when we are going from rectangular to polar. Polar to rectangular is not that big a deal, okay, as you can see. So keep that in mind. Make sure it's in the right quadrant. Make sure it's in the right angular form in terms of whether it falls in our interval when you're going from rectangular to polar, like we talked about there. So keep that in mind as you are doing this, okay? I don't want you to make any careless mistakes with that. All right, so now we do have some equations that we have to solve, and I know what you're thinking. Oh no, that's going to be difficult. Well, this is what I mean. Here's a rectangular formed equation. This looks like what we would use if we were to graph something in the rectangular coordinate system. Now, how do we change that to, folks, to polar coordinates? We'll go back to that pink box, rewind the video, go back to the pink box, or the pink box, if you want to turn in your book, is on page 424. Okay? Well, you know what this is, and you know what this is from the pink box. X squared plus y squared is r squared. X equals r cosine theta. Look at that. We just changed it to a rectangular coordinate. Now we can easily solve this. Factor out an r, and we're left with r minus 2 cosine theta equals 0. So you have r equals 0 or r minus 2 cosine theta equals 0 if you were solving this. So r would equal 2 cosine of theta. So you can discard r equals 0 because r equals 0 is part of this right here. R equals 0 is part of this right here. Because when cosine is pi over 2 or negative 3 pi over 2 or 3 pi over 2, any of the y-axis angles, r will automatically be 0 because the cosine will be 0. Okay? So hopefully that makes sense. So r equals 0 is contained in that formula here. So actually, the only thing you have to keep here in terms of the solution of this problem would be what's in the box right there. R equals 2 cosine theta. Now, what students have to get out of the habit of, okay, with this particular problem, students all the time think we're trying to solve and get an answer, a numerical answer here. It's going to look like this equation form. Please, folks, don't let that confuse you. Okay? R equals 0 is contained in here because, let's do a for instance, just so you can see it. If cosine is pi over 2, cosine of pi over 2 is 0, the 2 times 0 is 0. So that would give you r equals 0. So see, r equals 0 is contained in this answer here. So that's why you don't really need that. This one boxed answer contains all of that. Okay, so that would be your final reduced problem answer there. Okay, changing from rectangular to polar. All right, let's change from polar to rectangular. And here's the trick here, folks. I'm going to be honest with you. There are some of these problems that if you don't do this little trick I'm going to show you, it gets nasty really, really quickly. And I personally, and I consider myself a pretty good math person, obviously because I'm teaching it, but I consider myself a pretty good math person anyway, of being able to solve and manipulate problems. That's my specialty. This right here would be so nasty, I don't even know if I want to try to handle it if I try to solve it without this little trick I'm going to show you. So anytime you try to go from polar to rectangular, it gets messy. So a simple trick can make this real easy for you. Multiply both sides by r. So that gives me r squared plus 3r sine theta equals 0. R times 0 is 0. All right, now we're changing from polar to rectangular. So rectangular form is xy form. So going back to my pink box on page 424, I know what r squared is. R squared is x squared plus y squared. I also know what r sine theta is. Y equals r sine theta. So look there, I changed it from polar to rectangular. This right here, multiplying by that r, is going to be the key in a messy form and a completely easy problem like you see in front of you, okay? So keep that in mind. So let's look at one more example. Let's look at r squared equals r squared cosine of 2 theta equals 9. And let's get this in rectangular form. Well, it's already been multiplied by r because it's got the r squared. We don't have to multiply by r. Now, the reason we multiplied the last problem by the r is because we only had an r. We didn't have an r squared to begin with. Does that make sense? We just had a regular r on the last problem, not an r squared. Now, what we have to deal with in this problem is this right here. Okay? Now, when I think trig functions and when I think polar rectangular, this is what I think. My mind automatically thinks of these two functions right here. When I'm trying to change from polar to rectangular, rectangular to polar, this is what I automatically think of, these two. All right? So, how can I change cosine of 2 theta in terms of one of these two or both of these two? I just need cosine 2 theta in terms of sine and cosine, sine or cosine, something that will help me, because the 2 theta is messing me up. Because notice, this is just cosine theta. It's not cosine 2 theta. So I can't work with that like it is. But I do have an identity. I do have an identity. And my identity states that cosine squared theta minus sine squared theta equals cosine of 2 theta. Okay? That is an identity. So beware. You can sometimes making these identity substitutions will be key for you getting these right. Because now what I have here is r squared cosine squared theta minus r squared sine squared theta. Do you see where I'm going with this? Do you see the resemblance now to this right here? That's my goal, okay? So what I actually have here is r cosine theta squared minus r sine theta squared equals 9. So what do I actually have here? X squared minus y squared equals 9. And I have changed it from polar to rectangular. Okay? Hopefully this has been an understandable lesson to you. If it's not, please ask your instructor questions. And section 7.2 will be coming up shortly. Have a great day.